Welcome to AI Machine Learning Workshop, the tutorial before your tutorial, Part 8, brought to you by Blackmagic AI. So if you want to know more about us, go to blackmagicai.com. You can sign up on our email list, like us on Facebook, or subscribe to this YouTube channel. So remember, this tutorial series is divided into Part A and Part B. In Part A, we covered the theory and concepts in AI and machine learning. In Part B, we apply the theory, concepts, and tools from Part A to actual coding example. In this video, we will begin to apply all the concepts we have covered to create and train a machine learning model to learn the correct outputs for our exclusive OR example. So as a recap of what we covered in Part 7, we covered how neural networks can be trained using the backpropagation algorithm. We started our discussion by introducing the perceptron training rule, which works for simple, linearly separable classification problems, but it cannot be used to train more complex, multi-layered neural networks for non-linearly separable problems such as the exclusive OR example that we'll be covering in this tutorial. This led to the use of the delta rule, which is a mathematical expression to calculate the neural network weight updates needed to train the neural network. The delta rule contained a quantity called the gradient, which we calculated using the mean squared error to derive an error function that gives the relationship between the neural network error and the weights in the neural network. Then we used the delta rule in combination with gradient descent algorithm to find the amount to adjust the neural network weight to converge towards the weight values that give the minimum error of our neural network. We introduced backpropagation to help us use the delta rule with gradient descent to train a deep multi-layered neural network. So remember, backpropagation allowed us to recursively calculate the gradients in the deeper layers of our neural network. Let's get started on our exclusive OR machine learning example project that we will begin in this video. So this graphic is the exclusive OR solution we will be creating using a neural network. Our exclusive OR has a truth table, which gives us the two inputs and the expected output. So in our first column, we have x sub 1 and then x sub 2. Those are the two inputs. Each row represents data in our data set. So for example, in the first row, if we have two zeros in our inputs, we're expecting a 0 for the output. And if we have a 0 in the x sub 1 column and a 1 in the x sub 2 column, and then we have 1. This is the data set for our exclusive OR function that we will use to train our neural network model. And then if you see the graphic on the right, this is the architecture of the neural network that we will build to train our exclusive OR machine learning example project. Now in this graphic, we're going to show you the machine learning workflow that we will use for our project. So our workflow is divided up into 7 main steps. We have data preparation, which you see here, which we will prepare our data, and that data comes from that truth table we just presented in the previous graphic. Then we're going to have our feature extraction, where we extract the relevant features from that data. And then we're going to build our model, step 3 here. Then we're going to train our model. Then we're going to evaluate our model and see if it beats our specifications for accuracy. This is an iterative process. So once we get to the point where we're satisfied with our model, then we'll move on to step 6, in which we make predictions or inferences. That's where we use the trained model to get our actual outputs. And then 7, we serve and deploy our model, which we won't talk about in this video, but we will talk about that in the next video in this series. Now the tools we'll be using for our exclusive OR project are TensorFlow 2.5.0, TensorFlow Keras. So that's the Keras library that comes embedded with TensorFlow. And we'll be using the Google Colaboratory notebook. Remember, Google Colaboratory is the online tool we will use to go through our machine learning workflow. All of these topics were introduced in previous videos, so check the comments below for reference to the previous videos so we can give you a review of these Google Colaboratory and TensorFlow and Keras. Okay, so to begin our exclusive OR example project, we're going to go to the blackmagicai.com website, and we are going to scroll down to the bottom. and then you will see a link to our GitHub page. Now the link is also posted in the comments below in this video, so you can check it out that way also, but you can always go to our website. That'll be the launching point for all our different media channels. All right, so I clicked on that, and we will be going to the AI Machine Learning Workshop repository, so we'll click on that. And then we'll be going to the notebooks section because we'll be starting off with our Google Colaboratory notebook. Now there's a couple of notebooks in here. One is the exclusive OR project notebook. So that's the notebook that has the completed code solution and also has some documentation and the references. And also we have the one called the project template. So we'll be starting off with the project template, but you will want to open the exclusive OR project first, because otherwise you'll have to do a lot of typing, because we're going to go step by step in our exclusive OR machine learning solution, and it might want to copy and paste some things and not have to type everything. So let's open that one first. All right. Google Colaboratory is integrated with GitHub, so we can use GitHub as a repository for all our notebooks, and then we can share it publicly as we are doing here. All right, so this gives us, so this shows us the notebook we'll be using, but we want to open it in Colaboratory, and that's where we can actually edit the notebook and run the code. So to do that, just click on the Open in Colab button, and that will automatically open up a Google Colaboratory notebook. I forgot to mention you will need a Google Gmail account for this to work, so that's a prerequisite. So let's go back to GitHub page. And now let's open up the project template. All right, you can see the project template is just an outline of our project. The table of contents are headings for each of the sections in our machine learning workflow that we will complete. So let's open up this one in Google Colaboratory. Now I'm the owner of this document, so it doesn't ask me for permission. So you may want to, you may get a message that says, do you want to make a copy? So go ahead and say yes to that, and you'll have your own copy in your own Google Drive of this notebook. This is Google Colaboratory, so we have our table of contents section panel here, like a navigation panel, and then we have our kind of workspace here, which has the area where we can like create our cells. So remember, there's two types of cells. There's a code cell, which will have our Python code, and there's text cells. So the text cells are what I use for documenting the code and creating these titles for each section in our machine learning workflow. We'll start with our project title, and this is a text cell. So remember, a text cell just allows us to put, it's like a little word processing document, very simplified, like a text pad. So we can type our title in here, but I'm just going to paste it in. I copied it from the other one. These text cells, you can use markdown language. On the left side, I have an actual raw markdown code there, and then on the left is a preview of what it actually looks like. So once I paste that, I can just click away from it, and then I see the actual preview. This is our title, and then this is our truth table. So we need this to know what our results in our data set. The reason we're using Google Colaboratory is it's a web interface, so you don't really have to download any code, and it's already pre-configured with the tools that we need. So remember, we're using TensorFlow and the Keras library. So those are already pre-configured, so you don't have to worry about installing anything. Those are already here. All right. Now the next thing we'll want to do is we will want to add some imports. So in order to do the imports, we're going to have to add a code cell below the imports text cell. So remember, this text cell is just providing us with our headings for our different machine learning workflow. So we'll just click a code. We'll hover over the imports cell, and then we'll have an option for code or text. We'll click the code one, and then we'll get a code cell. So there's a lot of imports we'll need, so I'm just going to copy that from the completed. All right. This code cell is our Python code. So remember, we're going to be using Python, and what it does is it imports the different libraries and things that we will need for this project. So we look at the beginning, we're going to import something from the OS, the operating systems, and we have an import. We're going to import TensorFlow. Remember, we said we're going to use the TensorFlow library. So we imported that, and when you see this as TF, so that means we're defining an alias. So whenever we want to reference the TensorFlow library, we just made a little like nickname for it, an alias, call it TF. So whatever we need from the TensorFlow library, we'll reference it using the TF. All right, another thing we'll need is the NumPy library. So NumPy is a math library we'll use to create and manipulate matrices and arrays. So remember, we're going to be doing a lot of like matrices and arrays operations. So NumPy is a good library to do that with. And once again, we're using an alias as NP, so NP will be our NumPy. Now another library we'll need is pandas, and we'll be aliasing that as PD. So this is a data processing library. It has some cool functions to import files, CSV files, and transform them into arrays. Pandas also has something called the data frame, and that represents data as tables with metadata. So we'll talk a little more about that as we get into the project. TensorFlow has a lot of modules in its library. We're going to import the ones we need. So from TensorFlow, we want to use Keras API. From TensorFlow, we're going to use Keras, and from Keras, we're going to import sequential, which we'll explain what that is later. And then from the TensorFlow Keras layers library, we're going to import something called dense, dropout, and activation. So whenever we want to reference these components, and then we're going to need an optimizer, so we're going to import SGD, so that's the stochastic gradient descent optimizer. So remember, we talked about gradient descent. This is just another flavor of gradient descent. And then we have some additional things. We have matplotlib. We want to plot some graphs, so we'll import the pyplot library as PLT. And then you can ignore these other things for now. We'll talk about those later in a future video. Now that we have our code, we have to actually run it. So in order to run this code, remember a code cell, we run it by clicking on the run icon to the left. And then we'll say run anyway, because I trust this, my notebook. So you can see it's running. And also we're connecting to our runtime. So when you see this RAM and disk space appear, that means we're connected to our runtime. So it's completed running, and we can move on to the next cell. So the next cell is data preparation. And once again, we will need a code cell, write our Python code. So we'll click that, that gives us a code cell. Right after our imports, let's do another code cell. And then I'm gonna paste this code. And all this code does is it gives us a printout of the versions of the different tools we're using. So we want to know the Python version. So this is a shell command. Then we want to know, then we're going to print out our TensorFlow version. So remember, TF is our alias for TensorFlow. So it has a property called version that we can use. And then Keras, we're going to see what version that is. So once again, we're going to run our cell. And this tells us the Python version we're using, TensorFlow 2.5. As we said, and Keras is 2.5. So that's as we stated the versions we'll be using. When we print things out, it appears in this output window. So we have an output window that we can also use. All right, so let's go back to data preparation. I'm going to put a comment there. So remember the little pound or hashtag symbol just is a comment. So a comment is ignored by Python. It's just something for us humans so we can comment and document our code. So let's prepare our input data, because remember, we need input data, our data set, to train our model. And we're also going to need the corresponding Y outputs. So we'll be able to tell our model with this data, this is the output we're expecting, and it's going to learn the relationship between the two. So I'm going to create a variable called X. So remember, a variable is just a kind of bucket that we can hold data. So when I put this equal sign there, that means whatever's on I define on the right hand side can be referenced or is going to be placed into the variable name on the left hand side. We're using the NumPy library to create and manipulate arrays and matrices. So in order to access that, we'll use the alias. So remember, we gave it an alias in our input. So this is the NumPy array. And the cool thing about Google Colaboratory, it has a code suggestion and completion. So once you do the dot operator, it tells you all the things available in that library. But we want the array function. The array is a function, so it has parentheses. So that means we have to put input parameters into the into this function. So we want to create an array, and we want to reference this array by x. What is x? Let's scroll back up. So x is going to be these two columns. We need a x sub 1, x sub 2, and this is the data that's going to be in each row. So we're going to have column, 2 columns, and 4 rows. We can initialize our array with these values. So we're going to use the NumPy array notation. So that begins with a square bracket at the beginning. Hitting enter there. Let's format it a little for you. And then a square bracket at the end. In order to represent the rows in our table, we're going to do another square bracket. And then we're going to put x sub 1 and then a comma, and that's going to give us our x sub 2, and that's the first row in our data set table. So think of this array as like a kind of spreadsheet table. So this is a 2D array. So we have 0 and 0. So we have our first row and our x inputs. Now in order to create the second row, what we're going to do is we're going to create a comma. And the comma means we're doing our next row. And I'm going to put square brackets again. And then I'm going to put our next row in our data set. So that's going to be 0 and 1. So this is 0 and 1. And you can also refer to the NumPy documentation if you want to read more about the syntax for creating arrays using the NumPy library. All right, our next one is 1, comma 0, and we need one more row, so another row is going to be a comma in addition to our square brackets, and then I'm going to put 1, comma 1, and that's our final row in our data set. So you can see we have our 4 rows, so each square bracket represents a row, and the first element in that row is the first element in our square brackets array, and then the second element is the second column. So just think of each square bracket is a row, and each item in our square bracket row is the column value. Now what I want to do is print that out so we can. So I'm going to use the print function, Python function, and I'm going to put our variable x in there. So remember, variable represents that NumPy array, so we don't have, that's how we can refer to it or reference it. And then once again, in order to run this command and have it in memory, we will click the run for this cell. All right, and now we printed out our input values of our data set. So you can see we have our rows and our columns, and all we did was create a 2D array. So this is basically an array of arrays. So let's go to our next step, is the feature extraction. So once again, we're going to create another code cell. I'm going to put some comments here. I'm going to cut and paste these because I don't want to type it. Created a NumPy array, but we also have that pandas library, and we can create a data frame. Remember, a data frame is similar to the NumPy array. The data frame allows us to add metadata to our array, so we'll be able to add label information for our rows and columns. And the other reason we're using the data frame is that's the input, is the data structure it'll use for putting our inputs into our model and for our training. So we need this data frame format to work with TensorFlow. So I'm going to create another variable. This is called x. I'm going to do underscore df. So this is our x data in data frame format. And remember, data frames are from the Panda library, and we gave it an alias PD, and then I'm going to call the data frame function. It's a function, so it has parentheses that accept input parameters. And then to initialize it, I am going to first use the syntax for inputs into the data frame. So this is a curly braces, so I have two curly braces, opening and closing one. Now the first thing I'm going to put is the label for my first column. So I'm going to call that x of 1. So remember, data frames, we can add labels to our data. So the NumPy, we just had the rows and columns. There's no way to label them, but data frames allow us to do that, and you'll see why that's beneficial as we proceed in this project. All right, so the syntax for that is first I will create the label for that column, and then I will use a colon, and then I am going to get the first column from my x NumPy array. So to do that, I'm going to use the x variable, which is what we use to reference that array. I'm going to use the square brackets, and then I'm going to use something called slices. So what the slices syntax allows us to do with NumPy arrays is we can process those arrays and extract and slice them and dice them however we want. So for example, I want the first column in our array, so I'm going to use a colon, and by putting a colon, that means I want all the rows in that column. And then for the second parameter, I am going to put a 0, so that's my first column, and I have to do the same thing to create the second column, but this one's going to be x2. That's the label for that column. Oops, remember it's outside the quotes. And then once again, I'm going to reference my NumPy array x. All right, so x2 is going to be the same thing. It's going to be all the rows in that, all the rows, and then I want the column 1. So remember, NumPy arrays have a 0 starting index. So for the first column, I set all the rows in the first column of my array, and the first column is 0. And then if we count the second column, that's the next number, which is 1. So remember, NumPys are 0 indexed arrays. So the second column is all the rows in that column. So the first element in the square brackets are the rows, and then the second parameter represents column in that row. So we got all rows, first column. So that's our x1 and x2. And just to confirm that everything is correct, we will do a print, and we will print out x underscore df. So this is our x data frame. So let's run our code cell. Oops, I put an extra thing in there. So that's another thing. So if you have an error, it will also appear in the output area. All right, correct that. All right. All right, so now you can see the difference between the NumPy array and the Panda data frame. So remember, here we have our NumPy array, which has the same numbers in it, but it's not labeled. So here we were able to label our data. So now we can see it in the column and row format that's going to be required by the TensorFlow functions. Now another thing a data frame does is it assigns an index to your rows. So even if you delete a row, it will maintain that index. So if you want to reference row 1 again, you can do that. So you can see how it gave our labels for the columns, and then it numbered our rows. And it gave our rows index values. So we can also refer to our rows with these index values. So that's useful when you have lots of data. So one thing I want to show you is We can also clear the outputs in our cell. So if we want to clear all the outputs, we can do that, and it just clears the output area. So sometimes the output area can take up a lot of your screen and gets kind of cluttered. So you may want to remove that. Right. Okay. So remember, in order to train our model, we have to show it the relationship between the inputs and the outputs. So we also need to represent the output data as a data frame. So let's do that next. So that's going to be our Y. Okay, so these are the return values from our exclusive OR model. I'm going to do a NumPy array here. This is the one for Y. So we're going to do NumPy.array. So remember, some functions. Oops. Use code completion there. All right. And now we have an array out of arrays again, right? So we represent our array with square brackets. But remember, inside of that, we're going to create our row, which is also an array. Now for Y, there's only one column, so all we have to do is do like a 0. And then that's one row. And then our next output row is 1, and then we're going to do another 1, and then we're going to do our 0, and oops, it's a little lining up here. All right, so that's our Y input from our truth table. All right, so now let's create the data frame version of that. So I'm going to do Y df equals, we're going to use the Panda library, which is aliases PD. We need the data frame function, which takes parameters, and we're going to do the same thing. We're going to use the syntax for the Pandas data frame. We're going to use curly brackets, and then we are going to specify the label for the column, which is going to be Y, and then colon, and then we're going to specify a slice from our NumPy array. So remember, we're going to use we want all the rows. So the first element for the slice is all the rows. So to get all the rows, we just use the column. And if you want to look more about how the colon is used, you can also specify, you can use that colon to specify which particular rows you want. But we want all of them. And this is going to be Y NumPy array only has one column, so that's the 0 index. And then once we do that, we're going to print it out. And to print it out, we have to give it the name of the variable that contains our data. All right. And once again, we can run this cell and just confirm that everything is exactly the way we want it. All right, and there we have it. We have our inputs data frame and our expected output data frame. So remember, this first column is just the indexes assigned to each row by the Pandas data frame function. But our actual data is here under the Y label. So we have our X1, X2, and then our Y. So now we have our features in our data, and the next thing we want to do is build our model. So let's move on to that step. And also you can clear your outputs cell by cell by hovering over in the upper left of the text area in that X, and that'll clear your cell, your output cell. I'm going to paste some more reference documentation in our text cell. Twice. All right, and then I'm going to click outside of it, and that is all right. So now we're going to build our model, and this just shows the architecture of what we want to build. So we'll have this image and diagram to reference as we build our model. So once again, we're going to create a code cell. All right. Now I'm going to copy some comments in our code cell. Comments are good to document your code, so when you come back later, you'll say, what is this about? Or if you want to just like document, so you want to come back later, it helps you understand the code or what you were thinking at the time. So comments are good for, and also it helps if you're collaborating with other developers. They can read it and understand what your code is supposed to do. All right. So remember, we want to build this model. Now our model has the 3 layers: input, hidden, and output. So we want to build this model. What Keras provides us is something called a sequential, which is a linear stack of layers. So we want to build these layers for our model. So I'm going to define a variable called model. So this is going to represent our model, our neural network model. And I'm going to call the sequential constructor. If you want to know more data about the sequential, there's some reference links in the full completed solution to this exclusive OR model. So that's that other notebook that's in our GitHub repo. So all this says is I'm going to create a sequential object or entity or type of thing, and I'm going to assign it to a model. So whenever I want to reference the sequential object, I will use the variable name model. Right. Now the cool thing about sequential is it has a function where we can just like build our layers like a stack, just like a stack of pancakes. We just build them layer on top of a layer. All right, and to do that, I'm going to reference sequential, which is now the alias model, and I'm going to call one of its functions. Now one of the functions that sequential has is the add. Function. So with the add, I can add a layer. Remember, the input layers, they really don't do any calculations, so we don't actually need an actual physical layer for that. So we'll show how we designate that next. But I want to build this hidden layer, which has 2 neurons in it. So the way we do that is we use another entity or type of thing called dense. So remember, dense is just a type of layer that we can build using the Keras library. So dense also takes some parameters. So in dense, I can tell it how many neurons I want as the first parameter. So I'm going to put 2 in there. Then I'm going to put a comma. We don't explicitly specify the input layer, but we can do it implicitly by typing in the input dimension parameter and setting it equal to 2. So this is basically telling Keras that this first layer, it's going to have 2 neurons in it, and it's going to have 2 inputs. The input dimensions 2, 1 and 2. So that's what we have there. Now we want to add an activation function. So remember, our neurons have activation functions. You can refer to the previous videos in this tutorial where we explain about the different activation functions. But remember, we're trying to do the exclusive OR problem. So we need a non-linear activation function for this type of problem. So I'm going to specify the tanh. So this is one of the things when you're designing and coming up with your neural network models, you might want to experiment. You can experiment with like the type of layers, how many neurons are in each layer, and also the activation function. So we could play around and see if that gives you better results, or if it takes longer or it's shorter to train. So these are things you will consider as you're designing your models. All right, so we have just created a first layer in our model. So we have the 2 neurons here, represented by 3 and 4 in our diagram. Those are our input dimensions. So we got 1 and 2, those are specified. And we've also specified a nonlinear activation function. All right, so let's try to do our next layer. So once again, we're going to use model. So model is still representing our neural network. So it already has one layer in it. We're going to add the next layer to it. All right, we're going to use the dense type of layer. So there's many other ones, but if you look at the documentation, you can see if there's any other ones you want to use. But for our simple case, a dense is sufficient. All right, and once again, we have to specify the number of neurons. So remember, we're doing this output layer now. So there's only one neuron. And then I'm going to skip the input dimensions, because the cool thing about this library is based on the number of neurons, it knows like how many inputs there are. So, and it's the second layer, so it knows to feed in the 2 neurons, 3 and 4 from the previous layer into this one. So I don't have to specify it explicitly here. It figures it out on its own. But I do want to specify an activation function. And this time I'm going to use the sigmoid. Now remember, the output for the exclusive OR is binary, so the sigmoid is appropriate for this problem. So once again, the activation function lets you tailor the outputs in the ranges that you want. So we're going to use the sigmoid. All right, and now I'm going to create another variable to hold our optimizer. So remember, to train our model, we were using something called gradient descent. So you could specify the type of gradient descent algorithm. So there's many types of gradient descent algorithms. So we're going to use the stochastic gradient descent, which is similar to our explanation of gradient descent in the previous tutorial videos. Stochastic gradient descent offers the advantage of faster training, so that's why we're going to use this one. So it's a popular one to use. And remember, when we're using gradient descent, we have to specify the learning rate. So that's something I could specify here, learning rate. And the code suggestion brings it up for me. And let's see, remember it's a small number between 0 and 1. So let's start off with a 0.1. That's usually a good starting point. And like I said, these are hyperparameters, so these are things you can change to optimize your model. So we have stochastic gradient descent, which is another form of gradient descent. It does like kind of a random walk towards the minimum point in our gradient descent surface. We want to compile our model. So far we just described the architecture of our model to Keras, but now we want to actually build that model based on the description. So that's what we're going to call the compile. And that's going to take the information we've given it about the architecture, and it's going to create that model for us. Now, remember also in the previous video we talked about loss. So you could also specify loss, the type of loss you want to use. So remember, we're using mean squared error, so that's going to be MSE. The documentation will explain the different loss functions that are available. We can specify the optimizers, so there's various optimizers you can use, so we're going to specify that. And once again, you can experiment and see like what different optimizers there are, different loss functions you might want to use, and see if that gives you better results or trains faster or slower. So these are things you'll have to test to see what's the best for your project. So metrics, optional thing, but so metrics allow us to specify certain data we want Keras to collect while it's training the model. And remember, the metrics, we're going to use that to evaluate our model. So one of the metrics we can use is the binary accuracy. So as it's training, it'll collect this data for us and calculate it so we can use it later. So if we don't specify this, it won't, oops, spell binary wrong. So if we don't specify this, it won't calculate it for us. But this is an optional parameter that we can use to specify the type tag. And the reason we're using the binary accuracy is we're using exclusive OR model, which is a binary output, either 0 or 1. So that's a good way of evaluating our model. And another thing we can do is we can do print model and summary. Summary function. Now, when we run this cell, it's going to run our Python code, which builds and compiles our model, and then it's going to run this print statement. The model has a summary function which will display this table or information about our model, so we can look at it in kind of like a semi-text graphical format, so we can verify that the model is correct. So for example, we have the first layer is dense. This is its output shape, so it's 2 neurons. The next layer is 1 neuron, and then it gives us total parameters, trainable parameters, non-trainable parameters. So this parameters, if you'll notice, let's look at the output one first. There's 2 parameters related to this, the weights and then the bias value. So that's 3. And then we have 6 here because we have 4 weights that have to be trained, and then like 2 bias values. So it's 4, 5, 6. Those are our training parameters. So remember, we have to update the weights. So we're trying to figure out the weights so that our model provides the correct outputs given the inputs that we specify. Let's show another, let's add another code cell, and I'm just gonna paste this code in. It allows us to kind of visualize what our model looks like. So if I use the TensorFlow library Keras utils, plot model, I pass in the model, which is held in this model variable, because we built that. Remember, that's a sequential object, but we refer to it as model because that's the variable name we assign to it. And we're going to create a PNG image. So if we run this code, it gives us a simple visualization of our models. This is another way to confirm that our model is as we designed it. For the next step in our workflow in which we train the model, we need another code cell under our train model. So this is where our training code is going to go. In this step, we're going to train our model. To train our model, call the fit function on our sequential model, and we could specify something called the epoch, the number of epochs. So let's kind of explain this a little bit. So one epoch is when the entire data set is passed forwards and backwards through our neural network only once. So remember that truth table with our data, and then we made our data frame with the inputs and outputs. So once we presented this whole truth table and each row into our model once, that's one epoch. We'll also refer to something called the batch size. So that's the total number of training examples present in a single batch. So we have 1, 2, 3, 4 samples. So our batch will contain 4 training examples. So these are examples of what we want our neural network to learn. Remember, this training is an iterative process, so iterations is the number of batches needed to complete one epoch. All right, so remember, this is our batch size, is a total number, so we have 4 in one batch. So in order to complete one epoch, we have to present all this once. So iterations is the number of batches needed to complete one epoch. So we'll just need one batch for ours, so we'll have to specify that. So epoch is one of the parameters you can change. We'll specify a fixed number of epochs. All right, so let's specify a variable that's going to hold our epoch value. And I put this in a variable so we can just like change it here for clarification, but you can also put it directly in the fit function. Now I'm going to specify another variable called history, because when we train our model with the fit function, it's going to return a history object or entity for us. So remember, our model has been designed and compiled. So in order to train it, we're going to call the fit. So think of fit, the reason it's called fit, kind of fitting our output to the data set. All right, so the first thing it's going to need is our X data frame data. So remember, these are the inputs, so we have to tell it the inputs to use. And then we're going to tell it the outputs, Y data frame. So remember, we defined these variables previously, and they basically just contain, since our model is really simple, that truth table only has like 3 columns and 4 rows. Our data set's pretty simple, but as it's more complicated, you may divide up your data into smaller or bigger batches. And then we're going to specify our batch size. So remember, we can only present one training example to our model at a time. So we're going to say our batch size is equal to 1. And I have additional links to reference material explaining the batch size, epochs, and iterations in the completed exclusive OR project notebook. So you can look at that, and it has additional references. And then I specify the epochs. And since I've already defined that in a variable, I'll just use my variable. But I could have put the number directly in here if I wanted to. But so this is actually the training part. So let's train our model. There we go. So it's running through the iterations, epoch by epoch. Takes a while, so when that run button is spinning, that means it's still running. So now it's complete, and you can see the information that it spit out. So as it was training, it was outputting information about each epoch that it completed. So there were 500 because we specified a fixed number, 4 iterations in each epoch. Because remember, our batch size was 1, but our batch contained like 4 examples. So it took 4 iterations. And also remember our metrics, so that's displayed here also, and then our lost data. So this is a lot of information. There's like 500. We could have, in some models, you may require thousands or tens of thousands of epochs you want to specify. This is information about the training of our model, and you can see it's a lot of data, but we might want to represent it in a more graphical format. So I'm going to clear this because it takes up a lot of space. So I'm going to clear this output for this cell. So this is where we want to evaluate our model. So we've trained it, and remember, it's an iterative process. So if we go back to our diagram with our work, we want to make sure that it meets the requirements of the problem we're trying to solve. All right, so we will create another code cell for evaluate the model. So let's click on that. Code, paste. These are some comments here you might want to read. So remember, in the previous cell, we got a lot of data output as our model was training. So we want to visualize that. It'll make it easier for us to evaluate. So remember, fit returns a history object. That history object contains all that data we saw printed out. So we can query that history object to get information to help us evaluate our model. I'm going to create a data frame from the pandas library. And the history object has a property called history. So we'll get there. And I'm going to assign that to this hist variable, short for history. And now I'm going to do hist. So remember, hist now is my data frame. And I can index the data from that history object, because remember, in a data frame, the columns are labeled. So I'm gonna, I want to know about the epoch information. So I'm going to get that. And I'm going to create an epoch label in my data frame. And I'm going to assign the history dot epoch. All right. And then I'm going to do hist dot tail. So that's going to just give me the last couple rows in this data frame. So I just want to see the last couple of rows. All right. So I'm going to run this cell. All right, so you can see it gave me the last. This is a data frame, so it has labels for the rows. This is my loss. So remember we talked about loss. This is my binary accuracy, and this is the epoch number, which also corresponds to the data frame index but it won't necessarily always be that way. And using data frames for other types of problems. But you can see our loss. So remember, we consider it converged when the loss, there's no further improvements in the loss as we continue our iterations and epochs. So you can see it hasn't changed that much. It gets smaller and smaller, but there's not much change. So you can decide at this point, do you want to iterate forever to get the smallest loss as possible? Or is this satisfactory for your problem and you don't need to waste more time training it? So that's one way of evaluating our model. Now this next way I'm going to evaluate, I'm just going to paste the code in. I'm going to create another code cell, and I'm going to copy it from the other completed work notebook. And this one uses that plot library. So we can do a graphical plot of the history data. So remember, the history object contains basically a spreadsheet of like data related to our model and training. So once again, I'm going to plot our history object in graphical format. So I'm going to use this plot library. I can specify the data that I want it to plot. I'm going to do epoch, loss, and then I can label the axes and things like that. I can add a legend, and so forth. So I'm going to run this. And now you see it created a little, the library, I was able to plot the data from the history object and show it here. So you can see with our legend here, the loss is this blue line. So it started off, but as we continued iterating through the training, the data, presenting the data set over and over, our model accuracy improved to the point where there was not much advantage of continuing on. So if I can change that epoch maybe to 1,000, you'll see that there's not much advantage to going to 1,000. So I think initially I put 1,000 in, and I saw it basically converged at 500. So that's why I just made it 500. And then once again, you can see our binary accuracy. And once it converges, the binary accuracy improves there also. Okay, so our model is trained. We've evaluated, and we're satisfied with the accuracy of our model. It meets our specifications for accuracy. Now we want to make predictions. So that's where we actually use our model to get output results. One thing about training your model and testing it, so this is kind of the test phase. We're going to actually give it data and see if it gives us the correct output. One thing you can run into when in machine learning problems is something called overfitting. That's where your model trains on a data set and it perfectly fits that data set that you trained with, but it doesn't fit real data that may have variations from that. There are many ways to reduce overfitting, but one way is to divide up your data set into test data and training data. So that way your model trains on training data, but then you can evaluate it and test it using real data. So that way you can avoid overfitting. So one rule of thumb is 20-80, maybe 20% test or 80% training for the data. But our data set is so small, it really didn't apply to our case. But let's try making a prediction. First thing, to make a prediction, we have to present our test data to our model. So we need the test data in a data frame format. Create another variable called test data frame. All we're doing now is formatting our input data into the format that our model expects. So that's the data frame. All it is our X column input data. And I'm going to do it this way, but we probably could have also used our original data frame, but I'm simulating here we have different data for test than we did for training, which we don't. But so that's our test data that we want to input into our model. So in order to do that, let's print. And I'm going to give like a little caption for our printout. So this is the results of the model. And I'm going to put a new line symbol so that it prints out on the next line. Now this is where we actually use our model to make a prediction. So I'm going to do model dot .predict. And then I'm going to pass in the input data, which is the data frame we create, line 1. All right, so let's run this. Oops, spellings. Okay, so let's run this one and see what we get. Oops, I have another syntax error here. This is a 1 column, and each row represents output for the our truth table. So you will notice we don't exactly get 0 and 1. What we can do is if we round up or down, we can convert these values into 0 or 1 values. So I'm going to do another print. And then I'm going to do results again, label, caption. /in. Then I'm going to do another model .predict. I'm going to pass in our input test data, which is just our X columns, X input columns. But then once I get that result, I'm going to round. So I'm going to call the round function, and that's going to round our number to a given precision. All right, so let's run it again. Let's clear our output. All right, so you can see our rounding algorithm, things that are closer to 0 get rounded to 0, and things that are closer to 1 get turned into 1. So let's verify that this is the correct output. So this is supposed to be our exclusive OR. We got 0, 1, 1, 0. So if we go back to our truth table at the beginning, we see we have 0, 1, 1, 0. So our model is satisfactory and it's accurate. We've trained our model and it's giving the correct outputs we need. So we can consider this project complete. So notice how we did not write any code or logic to get these results. What we did is we created a generic model. We presented it with the inputs and the outputs. And we did that repeatedly in iterations and epochs so that it adjusted the weights that gave us the smallest error, was also provided with the correct output. So this is just an example of what machine learning can do. So we didn't have to write any code. All we did is create a model. We presented it with the inputs and outputs, and it learned the relationships between those in order to approximate the exclusive OR function for us. And that concludes part 8 of AI Machine Learning Workshop, the tutorial before your tutorial. So don't forget to go to blackmagicai.com, like us on Facebook, sign up on our mailing list. You can also subscribe to our YouTube channel and you'll be notified when additional videos in this series are posted. Thank you for watching.